In this part of OSIsoft's AMI infrastructure, we'll talk about what happens when you add a meter, and specifically how we add a tag to the Pi system, to the Pi server in the AMI infrastructure. Okay, and first off we're going to talk about the on-demand mode, which means creating tags on demand versus the pre-created mode. We'll talk about that in the second half of the video. So to start off, we have meters, and then we have areas where we want to view the data, and so we need Pi tags to accept that data. So we have a data source, we have a Pi interface, and we have the Pi server, which will ultimately store all that data. We also have the Pi AF server and the enterprise gateway machine on the side here. But we will concentrate in this video on the Pi server and how we create tags on that machine. Okay, so we're just drawing in boxes. Each one of these boxes just represents a piece of hardware, a server that houses the data source software or the Pi server software. And data flows from left to right, both usage data and, in this case, data that's necessary to create a meter. Okay, so we get a new meter. A new meter is added to the system, and how do we go about now creating a tag? So we have the head-end software. That's the stuff that will notice that there's a new meter and interact with it and collect data from it. And then on the far side we have the Pi server software. Now to start with, on here there is a tag database. So this is just a table that keeps track of all the tags that this Pi server has registered on it or has created on it. So if we have 1,000,000 tags, then there will be 1,000,000 tags in that tag database. Then there's the archive, and that just stores meter usage data. Now the archive has a spot for every tag in the tag database, which is part of the challenge here, because if we suddenly create a lot of tags, the archive might not have space for that many tags available. But we'll talk about that a little bit later when we get to pre-created. Okay, so PiSCC has in its heart, it has meters.table. So this is usually named according to the head-end software, then meters.table. And it keeps track of all the meters that are registered with PiSCC and all the Pi points that they need to write to. We can call this the master table, in fact. It's the central brain of the whole operation. So when a new meter is added, the head-end software will write an XML file in one method. It'll write an XML file, which will be interpreted by the meters.table, and that will create an entry into the table to record that, hey, there's a new meter available. Master table. Okay, very good. Now, once a new meter is added to the master table, it's going to be put into a queue to be created on the Pi server. There's also an edit queue in case we need to edit tags. So upon a new meter coming in, it's put into this create queue. And the reason we have a queue is because thousands of meters might be created all at once. And if we lost connection to the Pi server, we want to be able to pick up where we left off. Now, these are picked up by the Pi server and added to the tag database. Now, if there's an error, if there's any reason that we weren't able to create that tag, it will be reported to PiSCC, which will then put that command into a try again queue. So this will just attempt to create the tag again or edit that tag again if it didn't work the first time. And it will just keep trying until it succeeds. Now, what if we add lots and lots and lots of meters? Well, we could get into a problem. Like I said before, on-demand might not be sufficient. We might need to do something called pre-created. Now, the reason is that our archive usually only has space for a certain number of tags, and if we intended to put more tags in there, we would have made the archive much, much bigger to begin with. But we can make sure that problem won't be encountered if we just create a lot of tags in the first place. So before we install and start running PiSCC, we'll run something called AMI tag create.exe. With this, we can create a number of reserved tags. And these will be just named _reserved1, _reserved2. And what they allow us to do is to have a bunch of empty reserved spaces in the tag database and in the archive. So when we create those hundreds and thousands of tags, we already have spots for them. Okay, so let's talk about that data source again, and we have the Pi interface, and the Pi server machine. Very good. Okay, now one important note about this is if we use AMI tag create, it will create a file called the precache file. Now what the precache does is it informs PiSCC about all these reserved tags that are there, because PySCC otherwise wouldn't know about them. It's important that the pre-cached file is never deleted. It's a permanent record of all the tags that were reserved in the first place for PySCC to keep track of them. Once a new meter is created and it's put into the meters.table, the master table, if there is a reserved tag available, it will consult with the pre-cache file and then put a command into the deploy queue to rename that reserved tag to now match the meter, the new meter. Also, there's also an edit queue which allows tags to be edited as well, just like the on-demand mode. Okay, so we have a new meter, it comes into the master table, then it's sent to the deploy queue, and then it's sent out to the tag database on the Pi server, which will take one of those reserved tags and rename it into a new name for the meter. Okay. Similarly, we can edit tags the same way. Now, if we run out of reserved tags eventually, we can just create them, just using the same methodologies we did for the on-demand mode, using a create queue. And similarly, if there's problems, there is a try again queue, if there's any errors in editing or deleting or renaming tags. Now, say we had a problem somewhere in this, in creating a tag or renaming a tag. You'll want to troubleshoot, start on the right side of this diagram and move to the left, checking each one to see if the tag command got that far. So troubleshooting. For example, if we suspect the queues, we could use the queues client.exe, which is available in the PyPC folder, to look into those queues to see if the command is in there. Similarly, if we want to just look at the Pi server, we could use PySMT or the other array of Pi server troubleshooting tools. If we want to check if the meter made it into the table, we could use tablesclient.exe, and to check if the meter even made it to the head-end software, we have a client for that too. So this one will just be named after whichever head-end we're using. So the head-end, then test.exe. That'll allow you to look at the head-end itself or the XML file that is written to PySCC, sometimes containing new meter structures. And lastly, the pre-cache file. If we want to look into that cache file or any other file with cache in the name, there's cacheclient.exe, which will allow you to look into there. While you can safely browse any of these files with these client tools, you should never edit or delete any of them without specific direction from OSIsoft. Doing so could cause serious headaches. So, thanks for watching the video.